So an air mass is a large body of air. It has similar temperature and moisture all the way throughout it. And the way it gets that temperature, whether it's going to be warmer or colder or drier or, hot, or wetter, all depends over the area on that it's going to form. So remember, this air mass is invisible. You don't see it. You might be able to feel it, right? If it's like moving fast enough, or it will be considered wind, but it's basically just moving silently throughout. And you're going to need to write down all these terms, and you're going to see these terms come up over and over again. So from now on, every single time you see M, it's a lowercase m, and that's going to stand for maritime. That stands for wet. So a couple ways you can remember this is I don't know if you are familiar with Spanish, but mar means, I believe, the ocean. Marina would be like where something to do with the where you might keep your boat. Um, Marines, right, have to do with water, like submarine, underwater. So that's just one way you could think of it being wet. Continental would happen on continents, and that's land. So that would be like dry land. That's one way you could think about it. Tropical, if you think of like a tropical island that's generally warm, and polar, you can think of like the poles, like the North or South Pole, or polar bear or something like that would be ways to remember it would be cold. Now, you can't have a TP air mass, right? It can't be both warm and cold. That wouldn't work. But you can have MT, like wet and warm, or you can have wet and cold. Those two make sense. So that would always be the lowercase comes first. It'd be MT or M and P. So let's take a look at some of these here. So if this is the United States right there, let's just say it's North America to be more specific, you could see all these different, I'm going to put myself in the top left corner so you can see better. You can see all these different air masses. Now, this is coming down over here closer to the equator, so they're all going to be warm, and they're represented by red. So maritime, tropical on the bottom left and on the bottom right, because they both form over water. So that's maritime, water, wet, and the redness or the tropical is forming over where it is warmer. So it's all wet, warm air that's coming up over here, except for in the very center over here where you're going to get that continental tropical air mass over here over Mexico. That's different than the continental polar that's up here in northern Canada over the dry lands. But then you have the maritime polar on the top left and on the top right that's coming over with the waves. It's bringing over that colder air there. And if you look over here, I always found this interesting. So remember about the Coriolis effect, which we kind of talked about a little bit. As the Earth spins, right, the global winds are trying to move in one constant location, but they wind up getting curved because the Earth spins. So if you look over here, you can kind of see this is kind of a map that shows how dry things are. So it has a lot to do with rainfall. So if you look right over here on the far right, you can see that there's a lot of rainfall that happens all in these areas. And that's because it's right over here along. So we have the Atlantic Ocean here, the Gulf of Mexico, and that's moving inward. But the more inland over here, you start to see less of this water makes its way all the way over there. So this is going to be a lot drier. And you can see this right over here, right above Mexico, it's going to be a lot drier. But then you see how there's this little inlet right over here, this little waterway right over here. And if you go directly above that over here, you can kind of see that mirrored over here where this area starts to get a little bit more fertile, a little bit more rainfall happens over here. Whereas this particular area directly above that land is still very dry. But as soon as it starts to curve back inward, you can start to see, right, the arrow pointing back up over here. This water makes this area very, very wet over in this location, but it doesn't go in far enough. So it's just kind of interesting seeing how the geography impacts the amount of rainfall that happens per year in the United States. Now, I'm going to ask you to write down all these definitions. I know it's a lot, but you can handle it. So a front. I want you to think of a front as a boundary that forms when two different air masses meet. Now, these are almost like at war with each other, and that's actually where you get the term front from. It's like battlefront. I believe this all comes back to because back in, I think, either World War I or World War II, they really started to understand how weather works a lot better. And they had these wartime terminologies in their head, and that's part of the reason why they used it. So a cold front is when the cold air pushes underneath a warm air mass, and violent storms generally follow with kind of fair, coolish weather, so not super, super freezing cold. It's going to be cool and not an insane amount of, after the violent storms is when you just get like kind of normal-ish weather. The warm front is when the warm air mass moves over a cold air mass. The rain and shower follows by humid weather. So that's going to be more gentle, steady showers. You're not going to get that super violent ones. Now, notice in both cases, always cold goes underneath the warm, right? Because it's denser. So it's always going to go underneath no matter what. So what's the difference here? If it's always cold is on the bottom and warm is on the top, which is the difference? And the difference is which one is doing the overtaking. That is everything. So if you look over here, it's going to rephrase some of the things that I just said here. So there's your warm and moist. That would be maritime, tropical, cold and dry, hot and dry, right? So see them moving here. Did you see how as it moved over that area, it changed, right? Because it went over water. So I'm going to keep
These two air masses are referred to as fronts. Fronts are labeled in reference to the relative temperature of the air that is approaching and replacing the existing air mass.
So you see how this is intruding on it there?
Warm fronts, cold fronts, stationary fronts, and occluded fronts.
You do not need to worry about the last two.
Warm front occurs when a warm air mass overtakes an air mass of a colder temperature. Warm fronts usually move slowly, around 10 to 25 miles per hour, and have a gradual slope that will slide over the top of a cooler air mass and move it out of the area.
The reason that that's called the warm air mass is because the cold air mass is kind of just there doing its own thing, and then the warm air mass overtakes the cold air mass. It's the one doing the movement in that case. That's why it's considered to be a warm front.
Fronts usually contain high humidity and have more stratiform or layered clouds along the frontal boundary.
So you're going to get stratus clouds.
Drizzle and decreasing visibility will be present as temperatures rise. Once the front passes, rain showers are possible, followed by a gradual clearing. A cold front occurs when cold, dense air overtakes warmer air. Cold fronts move faster than warm fronts, averaging 25 to 30 miles per hour, but can go as fast as 60 miles per hour.
Pretty fast.
Cold fronts stay close to the ground and have a steeper angle than a warm front. They will move across the ground and lift existing air at a very rapid rate. This rapid upward motion will cool the air and form cumulus clouds, which could eventually develop into thunderstorms or even form a line of thunderstorms called a squall line. Once the front passes, the weather will clear and improve with general wind flow from the west-northwest. A stationary front.
So did you see how in that one right there, it's pushing that warm air up very violently, very quickly, and that is what's causing those huge cumulonimbus clouds that we talked about that stretch really long distances, and that's where you can get that really violent hail or really violent thunderstorms, and then of course a small percentage of those thunderstorms can go on to become tornadoes as well. So those are the two types of fronts. I know that there's other types of fronts out there. We don't need to go into every single one of them. As long as you can remember about the cold front and the warm front, those are the two most important ones for you to keep track of. I'd also like for you to please draw this symbol right here next to cold front. So here's the colder temperatures on the left and the warmer temperatures on the right. And we can see that this is a cold front because, of course, it is blue, right? So that's going to represent that it's going to be cold. And you can also see how the teeth marks right there. So those teeth marks, I'm trying to think of a way that you can remember that that symbol represents a cold front. You could think of like a biting cold or maybe like frostbite, something like that to remember. Maybe they look like icicles to you. However you want to remember that, that's fine. But that symbol on a weather map right over there is showing that the cold front is moving from left to right. How do you know it's moving in that direction? It's because those icicle-looking things or those triangles are pointing in that direction. So that is the direction that the cold front is moving in, and it's bringing that cold weather and possibly thunderstorms with it. So this would be an example, right? The cold air is overtaking the warm air, forcing that warm air up. That's a cold front. So you can see this more realistic diagram right over here, and you can see the shape of the cumulonimbus cloud forming because of it forcing it up like that. And then that was really intense, but generally short-lived weather systems that happen. So they kind of happen really quick, and then it's over after that. Now this next one is the warm front. So notice a different symbol. I'd like for you to draw this symbol right over here. I love if you have your colored pencils to actually draw it in the correct color. So the last one would have been blue. You keep this one as red. And now this warm front is moving in like a northeastern direction. You could see right over here. So it is in circular form. You can maybe think of like little mini suns, like a sunrise or something like that, or a sunset. And that could be your symbol for the warm front. Now notice here, you have a cold front on the right side over here, cold air. Here's the warm air on the left. And this warm air is just overtaking, is moving right over. And you see how it's stretching that long line? That's where you're going to get that long line of stratus clouds right above it. And it'll just be stationary for a long time. You can see that over here, those stratus clouds are just hanging over, and it's just this extended amount of precipitation for a long time. And then here we can take a look, and like now we can see some of these patterns on it, like on a map, to see what it looks like. So again, you don't need to worry so much about the stationary front. That's more of just when they kind of like get stuck and they're like in a equal battle right there, and they're not really moving that much. And occluded front is a little bit more complicated. They barely even show that on this thing, so you don't need to worry about that. But you can see how here's a cold front moving down. It's coming up from the Canada area, moving downward. You can see how here is a cold front moving down this way, but a warm front is kind of in the middle between the two. So you might argue that that is a stationary front right there. And you can see how it's kind of intermixed between them. Right? And you see how it's a little bit colder in general. That's why they have blue for the high pressure, and that's the H right there. And then the low pressure is because low pressure, remember, it's the air is rising up, so it's warmer, so it's not getting pressed down as much. If it's getting pressed down more, that's high pressure, and then it'll be colder. So just one way that you can help remember those things. And then the last thing I'd like to show you is I'm definitely going to attach this. This is a really cool video of a meteorologist explaining some of the weather things that I explained to you, but in a much better, more professional way. And the last thing I'd like for you to take a look at is here is a radar time lapse. This is February of 2019, and you can just see how it looks like it's just appearing out of nowhere, right? It's coming originally from the water generally. But this is like the weather. Where is it originally from, and how does it spread? So remember, it almost looks like there's this invisible thing pushing it along. Well, that would be, of course, the global winds are doing that, but also you can see it's actually following the jet stream a lot. That jet stream is constantly moving from west to east, or from left to right in this case, pushing those systems along. So sometimes a system can get trapped underneath. You see how sometimes a system makes its way all the way up here to, like, let's say New Jersey, and other times it gets caught way down over here. And you can see how certain places just seem to get hit with it a lot more than other ones. So it's going to be a little bit more drier in certain areas, hence the climate that you're going to get there. And then it's going to be more temperate and more rainfall in these areas.